One more thing I'd like to point out is that this is the total acceleration. Okay? So the magnitude of the total acceleration, which is at squared plus an squared, it takes square root. Okay? So at squared has the magnitude of this much, an, or at has the magnitude of this, an has the magnitude of this. So the magnitude of a total would be this much. Okay. So this is a total vector. Okay? So this is a relationship. Okay? At and an components of the total acceleration. Okay? So this, I think is right. Total. Okay. Let's look at an example. I have a particle traveling along a circle. And the circle is 13 meters in diameter. So the radius curvature is simply half of it, 6.5 meters. So this particle initially, V0, is at 4 meters per second. And it's traveling counterclockwise. This is the starting point. So you say start. Okay. So starting point has initial velocity of 4 meters per second. And sometime later, it ends up having a velocity of 7 meters per second. So it has increased. Okay, so it's gone through an acceleration. Okay, from here to here, and it's given that from the beginning to this point, okay, it has spanned 30 meters. Okay, so that is the arc length of 30 meters. Now, you're asked to find what is the velocity 2 seconds after this starting point. So velocity equals what? Okay. After 2 seconds. So you're asked to find the velocity. Okay. And you know that this is accelerating. The particle is accelerating. So what is that acceleration? Well, that's the key. Find the acceleration. Okay. And once you found that, then you should be able to find V. Okay. Because knowing acceleration and knowing the rest of the quantities, you should be able to find V. Okay. At any instant in time, okay, along this path, okay, as long as the acceleration is known. So let's first find the acceleration. Looking back in here, for a tangent normal coordinate system, there are 2 components. There are always 2 components of acceleration: tangential and normal. This tangential component is always tangent to the path and is related to velocity. Okay, it's the derivative of velocity. So, knowing that the velocity, okay, of this particle, okay, is 4 meters per second and 7 meters per second at these 2 locations, and then the distance is known. So knowing the end velocity, knowing the distance, this tangential component of acceleration can be found. Okay. So the tangential component we're actually looking at constant acceleration motion. Okay? So when acceleration is constant, you go back to one of those three equations. Okay? And the equation that will allow us to find the acceleration would be this equation right here. V squared equals v naught squared plus 2a times displacement. Okay? Except we apply this in this curved path. Right? So this would be v1, the final velocity squared, equals v naught, initial velocity squared, plus 2a. Now that's just not any a. This is tangential component of acceleration. Okay, so we're strictly looking at the tangential direction, times s minus s naught, which is the change in distance. This is exactly this arc length. That's 30. So, knowing these two end velocities, okay, beginning and the final velocity, and knowing this, so tangential component of the acceleration can be found. So just move things around. So v1 squared minus v naught squared over 2 times s minus s naught. Now plug in the numbers. v1 squared is 7 squared minus v naught is 4 squared. So it's like 2 s minus s naught. Okay, this is actually s1 minus s naught, the final minus initial. So, which is the change in distance, so 30 meters. So you plug in numbers. So the tangential component of acceleration can be found 0.55 meters per second squared. So knowing the tangential component of acceleration now, which is a constant value, okay, tangentially. So we can use this to find the velocity at any time, any instant in time along the path, as long as the tangential component of acceleration remains constant at 0.55. So after 2 seconds, okay, again this is constant acceleration, so we can use one of the other two equations to help us find velocity. And the equation would be v equals v naught plus a t. This equation, okay. Except now this is the final, the unknown velocity, which is you write v 2 seconds. Okay. So that's the unknown equals initial velocity 4 meters per second plus a tangential component of acceleration times time. So this simply equals 4 plus 0.55 times t 2 seconds. So crunch numbers, it gives you 5.1 meters per second. So that's the velocity of the particle 2 seconds after the starting point. Okay. So I can also ask you, what is the total acceleration? So just use the equation that I developed earlier. So total acceleration equals tangential acceleration squared plus normal acceleration squared. Now tangential AT has been found. Now your job now is to find AN. Okay. AN, just use the definition of AN, is equal to V naught V squared over rho. Okay. Now V is different at any given instant time. Okay. So you have to find the total acceleration after 2 seconds. Okay. So at 2 seconds we know that this is the velocity. So this is simply 5.1 squared. Rho is 6.5 meters. Again, just crunch numbers. AN equals 0.4 meter per second squared. Therefore, A total equals AT, which is 0.55 squared, plus AN, 0.4 squared. Add them up, take square root. So this is your total acceleration.